Kia ora Year 12. Here's the second calculus video that I'm doing to go over some of the basic skills. So actually this video is not quite as basic as the last one. We're going to look at how to find where a function is increasing or decreasing. Now I'm going to start with a couple of exam problems and then do 2 examples for you to work through. And then in the Walker workbook, the pages on this are pages 31 to 32. This follows on pretty closely after the idea of turning points. So the first thing we need to discuss is what does it mean for a function to be increasing or decreasing. So it's time for some bad drawings. Suppose that I've got a function f of x. So if we have to find where it's increasing, we are looking for the places where the gradient is positive. So it's going to be increasing here, and it's going to be increasing here. So if that function is a cubic, we can use our ideas from graphing about the shape of the curve to help us. So if it's a cubic that goes up, down, up, there are going to be 2 regions where the function is increasing. Right? So the definition of a function being increasing is that f dash of x is greater than 0. Sometimes you'll see it as a weak inequality instead of a strict inequality. It doesn't matter too much. I usually work with a strict inequality, okay? Because where it equals 0, we actually have a turning point, okay? So the other one obviously is where is it decreasing, and it's decreasing when the gradient function is negative. When I'm working with questions about increasing or decreasing functions, I always try to at least sketch the graph. And you're really lucky, you can use your graphics calculator to do that, and that lets you see what your answer is going to be like. So on the next screen, I'm going to show you an exam question from, I think, 2015, and it goes like this. So we're given a function. Here's the function, and we're asked, for what values of x is f a decreasing function? Justify your answer. So what I've chucked onto the page there is a GeoGebra snapshot of what the function looks like. But you can do that just as easily using your graphing calculator if you go to the graph menu and then draw. So we can see that our answer is going to have 2 bits, right? So where is f a decreasing function? Well, the gradient's negative here, and then it's negative again here. So our answer is going to have 2 separate sections. And what we're going to try to do is to figure out the cutoff values for those 2 sections. And as usual, we're going to start by differentiating. So let's first of all just write out, let's change pen color. Right, so the function is f of x is equal to 8 plus 3x plus x squared minus x cubed over 3. And I don't like working with the x cubed over 3 like that, so I'm just going to rewrite it as follows. 8 plus 3x plus x squared minus 1/3 x cubed. Now that makes sense. My graph is a negative cubic, so it's going down, up, down. Let's differentiate as the first step. So f dash of x is equal to 3 plus 2x minus, and we've got 1/3 times 3. And then it's x to the power of 2. So that conveniently, this bit here, simplifies out. And we need to find when the function is it increasing? Decreasing. So when's the function decreasing? So we need that gradient function to be negative. So we have 3 plus 2x minus x squared is less than 0. Now I don't like working with a negative x squared term. I'm going to be solving this in equation. So I'm going to times both sides through by -1. And that gives me -3 minus 2x plus x squared is greater than 0. Rewriting that gives me x squared minus 2x minus 3 is greater than 0. And that's a very nice, easy to factorize quadratic. If it weren't, we'd use the quadratic formula or completing the square to solve it. But here, this is where we get to. We get x times x. We want 2 numbers that times to give me -3, so -3, and they have to have a gap of 2. So we've got this. We've got a little parabola, and we can sketch that here. So this is my graph. the gradient function. It's got one critical value here and one critical value here. It's a very badly drawn graph, but that gives us what we need. So what we're looking for is when is this function above 0. So x has to be greater than 3 up here, or x has to be less than -1. The last thing that we're going to do is that we go all the way back to our first graph and check that that answer makes sense. Right, so we should probably write that f of x is decreasing when x is greater than 3 or x is less than -1. Let's see if that fits with what we've got here. Yep, that matches exactly, right? So I deliberately made it that you couldn't just read the values off totally from here, but you can see that that looks perfect. Just notice that it always says in the level 2 exam you must show the use of calculus. Okay, so you can't just use your knowledge of graphing features. Right, let's do the next one, and then there are 2 for you to do. So this one is very, very similar. I think this is the 2018 exam. Use calculus to find the values of x for which this function is increasing. Now, in those 2 papers, this was actually an excellence question, but you had to work quite thoroughly. So again, the first thing to do is to look on your graphics calculator and think about what your answer is going to be. We're going to have 2 places where the function's increasing. It's increasing here, the gradient is positive there, and the gradient is positive here. So let's start off by differentiating. F dash of x is equal to 2/3 times 3x squared plus 9 over 2 times 2x minus 5. So that equals 2x squared plus 9x minus 5, and we need to have that being strictly positive. So this is a slightly harder quadratic to factorize, but if you look at it, we can try doing this one by guess and check before we try grouping. I'm saying that because 2 is a prime number and so is 5. So let's give it a go. If we put 2x here and x here, and we're looking for one number's going to have a plus and one's going to have a minus, and we want a gap of 9. So let's try 5, and this has got to be 5 and 1. So if we plonk the 5 down there and the 1 there, and we put a plus here, that's going to give me plus 10x. Take away 1x gives me my plus 9x. So that's good. If you're not confident with that, you can use grouping, or you can try using the quadratic formula as well. Now, again, in here, there are 2 critical values. Right? So by critical values, I mean the solutions to each factor equation. So critical values are 2x minus 1 equals 0. So 2x is 1, x is 1/2. So that's going to be a switchover point. And the other one is x equals -5. So looking at our graph, what have we got? Well, here we need this thing to be positive. And again, this is a parabola. So this is my gradient function. It's a right way up parabola, and it's got one root here, and it's got the other root here. So it's positive here and here. So we have x less than -5 or x greater than 1/2. Okay, 2 more for you to try, and I really do recommend that you try these. Don't just turn the video off. You won't get good at these problems unless you do heaps of examples, because you can see there are quite a few linked up steps. Right, so here's the next question, and I've done the graph for you. So for what values of x is the following function increasing? So let's start by differentiating. dy by dx is equal to 6x squared minus 1/2 times 2x minus 7, and we need that to be strictly positive. That gives us 6x squared, and we should write that in for increasing function. We need dy by dx to be positive. Right, so 6x squared minus x minus 7, strictly greater than 0. Again, we could do grouping on this, or we can do this by guess and check. So I'll do it by guess and check first, then I'll remind you how grouping works. So I'm doing this because I've got 7 here, I've got 6 here and a gap of 1 here. So it feels like something with a 7 and a 1 might work fine. If we put the 1 here and the 7 here, I go take away 7x here plus x, 6x here, that works out fine. The critical values will be x equals -1 for this one, or 6x equals 7, so x equals 7 over 6. Right, so what I'm asking is, when is this thing positive? This is an up the right way parabola. So let's sketch it as usual. So we've got -1 here, 7 over 6 here, whoosh, there's my parabola. So it's positive. Oh, so far all of these ones that I've done have got 2 parts to the answer. So it's increasing when x is less than -1 or x is greater than 7/6. Look back at our original function and that works perfectly. There we've got one increasing bit here and then we've got a separate increasing bit here. Last example. So for this one, when is the function decreasing? Now this time you can see that we're only going to have one part of the curve where the function is decreasing. We want a negative gradient and it's happening in here. But we still have to do the same thing and figure out what these cutoff values are going to be. So dy by dx is equal to 3x squared minus 13x plus 4. And that has to be negative. We can try and factorize this. So we get 3x here and x here. I've got a plus here and a minus here. So it's going to be a minus, minus. I'm going to try 4 and 1. Right, so 3x squared, that works. Minus x minus another 12x plus 4. If you're watching this and you're feeling squeamish about this skill, it's one that we learned early in the year in algebra. I've set Dr. Frost on this, but a lot of you haven't done it yet. It might be time to go over your factorization. So now we get critical values. And from this one we get x equals 4. And from this one we get 3x equals 1, so x is equal to 1/3. Now this time, the function is decreasing for x in between these two values. So we can write that like this. 1/3 is less than x is less than 4. So there you go. Hope that helped. Remember, as usual, heaps of practice makes these easy, and the Walker book's got some great questions. Some of them are easier than these ones because they start with the function being just a parabola. All right, let me know if you've got any more questions on this.